Hello everyone. I have a mathematics midterm exam soon and I do not understand listening. I understand nothing when I listen and I forget very easily. And I don't know, the type of listening is not my um way of learning. Instead, I am the person who can learn by speaking, so I am doing this stupid thing again and again, and no one watches it. But okay, by the way, this is helpful to me, so I do this a lot. And you guys are maybe noticing, like, my type of writing, my type of trying to understanding is always changing. The first I showed my notes, like handwritten notes on a notebook in a realistic way. And the second, I wrote on my iPad by myself. And now this is the already written note on GoodNotes. GoodNotes was very helpful to me because you guys seeing this and I really like this feature. I love it. And this is very beautiful to make notes on GoodNotes, and I loved it a lot. Okay, by the way, and maybe doing exercises and speaking, teaching, these are the most helpful things to me. And honestly, I am understanding really nothing. I understood nothing and I forgot everything. So we gotta learn together. Maybe I am talking wrong, but I don't care. We gotta learn together now. Okay, let's begin. So the first topic was logic and proofs. And the first thing we need to know is preposition. Preposition is the sentence which is able to give answers true or false, but not both. Which is very understandable. Like you cannot say both, but true or false. For example, what to say? What to say? What to say? I don't have any idea. I really don't have any idea. Maybe. Okay, maybe. Cat is animal. Cat is animal. This is true. And on the other hand, cat is furniture. This is false. But cat is not both furniture and animal. So this is what I mean. Preposition is the sentence that you can say true or false, but not both. Like you can't say both after saying true, or you say no, false. Then what is this? This is obviously no. Okay. And a preposition example is a fact. For example, 1 plus 1 equals to 2. And on the other hand, questions and instructions cannot be. For example, do you live in New York? You can't say that question is true or false because question is not defining something, okay? And instruction is also not able to give the answer true or false. So they are not preposition. Position. Okay. My handwriting is terrible. Okay. Because you cannot say or know which has the answer true or false. Yeah, these are not preposition. Then, what is this? What happened to her? Okay. Prepositional statement. Prepositional statement variables is the way of expressing with the use of letters. Okay, like in this case, the prepositional and statements, they are same. Their meanings are same. Okay, so the question, no, the sentence which can give the answers true or false variables is the way of expressing with the use of letters. Okay, so in this case, you can say them. You can express them with letters, and like, what does it mean? It's possible to express everything by letters? I don't understand this case. Verse is the way of expressing with the use of letters. Like maybe there's the word variables. So if there's a variables there, you can express with the letters. I don't know. God. Okay, here's the example. It is raining. Raining is so P, and it is not raining. P, and over the P there is a line. So this is a negation. And the negation is not. If there is a not in the sentence, this is negation. Okay? And you have to see this too. And this is not negation. So what is it? This is preposition. I think this is the letter P, so this is maybe preposition. So over the P, this line means negation. This is just my suggestion. I don't know which is correct or not. Okay, there's a... what is it? Oh, I forgot. Okay, what about there's a thing expressing the difference between preposition and negation. Negation is the reverse of letter or sentence. So if a preposition is true, then this is false in negation. Look at this. Then this is false. This is very wrong. What happened to her? No. Okay, by the way, I wrote it really wrong here. If a preposition is false, then it should be true in negation. True. T. This should have been T, not F. This is wrong. Okay. I like this parts. If the sentence has and or but is in case of sometimes. Okay. So the type of writing in mathematics is P and this sign, I don't know what it is, and Q. So true, then equals to true. And false otherwise. Okay? This is a conjunction. If the P is true and the Q is true, then this is true. Okay, what should I say? Okay, I have a hand and I have hands and I have a leg. I have legs. Okay, I have hands and I have legs. So, this is true. But I have hands and this means I don't have legs. So, this is false. Okay, I think I don't understand this case. I really don't understand. Oh, and I watched another YouTube video and he was saying that, what was that? I live in California and I live in Los Angeles, something like that. So maybe this example is more understandable, but okay. I don't care. So the most important thing to remember is just this: true, true, true. Then others are no. These are false. Okay. And this is the truth table for the conjugation of two prepositions. And here is or. Okay. In this case, false, false, then false, and true otherwise. You have to focus on here, and others are true. Okay? There's a or. I have hands or legs. So, if I have hands and legs, this is true. And if I have hands and I don't have legs, this is maybe possible true too, because I use the word or. Then I say I don't have hands and I have legs, then this is true too. But if I don't have hands, I don't have legs, then I'm saying I have legs or hands, this is false. Oh my god, I made sense in this example now. And there is a true difference of or, the word or, or. One is inclusive or, another one is exclusive or. Let's see inclusive or. Inclusive or is true when at least one is true, possible for both. So inclusive or is just what we said about just recently, okay? And the example is students who have taken calculus or computer sciences can take the class, something like that. And exclusive or is students who have taken both calculus and computer science course cannot take the class. And so exclusive cannot be like this. And these are okay in exclusive case, but in inclusive case, these are both okay. Okay? Am I making sense? Then there is the or but not both. And the way of expressing it with letters with a shorter way is this. The circle and the two lines, which is like window. Very pretty window we see in the cartoon. Well, and this is false when both and true when only one is okay. So this is the exclusive or. This is the example of exclusive or. Yeah. Or but not both. So I have to say I have hands or legs but not both. So okay, I have hands, but I didn't say and, I used or and not both. Then it should not be true. This is okay. You have to focus on it, and if both are false, then it's also false. But one of they is okay. This is okay. Like what is said on this words. These words. Okay. True if one is true, the other is false. Yeah. So true. And this is a truth table of compound statements as summarized. Let's see. Okay. These are not that much important, but by the way, true, false, false, true, 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 and false, false. Okay. And this is the way of expressing in and. So if both are true, then this is true. But others are no. And this is the sign of or. So in this case, if everything is false, then false, but others are very okay. Yeah. We did not have review of them, so we gotta see them a few moments later. Okay, here it is. Conditional statement, which is very popular in this topic. During the first weeks of my colleges, like I was so completely lost. Like what is this? Like what? I don't understand what's going on, and I could understand really nothing. But this is seeming very easy now. So if something, then this. So P to Q. If P, then Q. So, oh, now I got it. I forgot I wrote it. So P is hypothesis, or antecedent, or premise. Or premise? I don't know. And Q is conclusion or consequences. Okay. If people woke up now, then it's morning. This is really good example, I think. Yeah. And the conditional statement is also can be said as implication. This is very difficult word. This is a very new word to me. I have never seen word implication before. I have never used this word before, so this is very difficult word to me. And P implies Q. Q follows P. A sufficient condition for Q is P. Q is necessary for P. Then you gotta use this. Okay? And in the implication, if the hypothesis is true and conclusion is false, then this is false. Okay, this were the one example in the book. I remember very well now. Okay, you gotta have been elected. Okay, someone is being elected. Someone is being elected. Okay, there's been election. Then that person is saying, if I become president, then I will what? I will build metro. So in this case, if that person became a president, okay, true, then that person made metro, true, then in this case this is true now. Then that person did not win the election and he made metro, then this is true. He made the thing he said what he wanted to say, but he did not win the election and he did not make metro, then this is true too, because he said, if I become president, so this is true too. Yeah, he said true. But he became president but not making the metro like he said, this is false. Where is he? This is like promise. Like promise. Okay? On the other hand, there is a biconditional statement. Like I watched a YouTube video also. Like if the P and the Q is true, then the Q to P is also true. Then this is biconditional. Okay? I guess it was very understandable. So in the biconditional statement, you gotta use these words: if and only if P is necessary and sufficient for Q. If P, then Q, and the P holds if and only if Q. Then you gotta use biconditional statement. And also you can say them as the equivalence. Okay? So here, true, if hypothesis is true and conclusion is true, then this is true. And if the hypothesis is false and the conclusion is false, then this is false too. And on the other hand, if they are different, they are false. They are opposite of or but not both. Look, they are opposite, okay? And like I say, we need to review over this part again. This is if P then Q. In this case, if the president did not do his promise, then this is false. And on the hand, these are true. Others are true. And where is that? Oh god, there is no hair. Okay, so in the biconditional statement, this is false, and this like different ones are false, and the same ones are true. Yeah. And those are some words. If P true, if P, Q have both same values, and false otherwise, okay. And I think they are way of proofs, or not the way of writing. I don't know. So hypothesis, line, conclusion. This is statement, and changing them is converse. And then contrapositive is not Q and then not P. This is contrapositive. And the statement is turning to converse, and this is if this is true, and the contrapositive should be true too. And if this is a false, then a contrapositive will be false too. And the inverse is not P and not Q. I can express them with letters, with words as well. Okay, by the way, here's example as well. I did not expecting I wrote some examples. Okay, so hypothesis is students take math courses, and the conclusion is students learn how to solve problems. Statement: if students take math courses, then they learn how to solve problems. Okay, if then. And the converse is, if students learn how to solve problems, then they can take math courses. I don't know which is true now. Okay, contrapositive is, if students don't learn how to solve problems, then they don't take math courses. And inverse is, If students don't take math courses, then they don't learn how to solve problems. This is very true. I think inverse and statements are same. They're having same meaning. And this is the much bigger type of expressing them, which is like the same like before. And the negation is changing them. If that was a true, then it's turning false. If it was a false, then it's turning true. And the implication, the promise is not went true as said, and this is false. And in the verse, this is different now. Then they are no same. Then this is a contrapositive. It was a converse. It was a converse, and it was a contrapositive, and it was inverse. Oh God. And I think contrapositive implications are same here. I don't get it. Okay. By the way, let's move to another part. Oh yeah, we have a tautology and contradiction. Tautology is always true, and the contradiction is always false. Okay, so if they are both true, then this is a tautology. If they are both false, then this is contradiction. Okay, very easy. And there are some laws here: double negation law, commutative law, associative law, distributive law, and De Morgan's law. Oh God. They are looking very hard to understand. Okay. If not P went through not P, then this is equals to just P. Okay. Not animal. He is not animal, so he is animal. Okay. And in this example, P and Q are changing the their position, and they are still same. And yeah, it's possible when this turns into P, like this commutative, like changing the position is still the same. Changing the position is not changing. Okay. And here is associative law. Associative law is like here is something a bracket and a bracket, and changing the bracket and what letters are inside is not changing as much. Okay. And then distributive law. In distributive law, yeah, this is like there is something like this. Okay, let's see. And oh God, there is some rule like this. This is exactly looking like this. I don't know how to explain it in other way, and I think everyone knows this rule. And in the De Morgan's law, yeah, which is very possible. And where is it? Oh God, this is like, oh God, like the law I just wrote here, like that was maybe algebra law, and which is like this too. I don't get it. I can forget it. Okay, there are an application to logic circuits. Yeah. This is the type of expressing inventa, and this is an OR gate, and this is an AND gate. Okay, if there is a shape of like this in the drawing, and then this is an and which is like a bird, or like I forgot the word that I had in my English class, and the birds are going here, the birds are here, okay, and there's water, and the water is becoming like this. Or it can be possible when the boat go here and the water is becoming like this, exactly like this, and this is or. And the inventa is turning this into negation. Okay. I hope it made sense. Okay. Which was very similar, but yeah, I said it. This, they are not same. They are inverse of each other. Inverse of each other. Yeah. If you say or but not both, okay, so it can be one of them but not both. Then if you say if and only if, this is okay having a both, then this is not okay one of them. Okay, here is predicate logic. A predicate is a declarative sentence whose true or false value depends on one or more variables. What does it mean? A predicate is a declarative sentence whose true or false value depends on one or more variables. Okay, it depends on many variables, and the true or false is dependent on more variables. Okay, for example, x, y, or depending on x, y, or z, and this is a predicate. Okay, here's a quantification. Quantification expresses the extent to which a predicate is true over a range of elements. And the words all, some, many, none, few are used in the quantifications. And the quantifications has two types. One is a universal quantification, and one is the existential quantification. And the universal quantification is a predicate is true for every element under consideration. On the other hand, existential quantification is there is one or more element under consideration for which the predication is true. In universal, there's every, and in existential, there's one or more. Yeah. Here's the predicate calculus, the area of logic that deals with predicates and quantifiers. I think here it is. The end of our class. Thank you so much. God, my English has been very terrible lately. I'm sorry.